So in a previous video, I modified a RS232 level converter for a DB25 because I didn't have one, and I went ahead, since I couldn't find anything online, and designed up a single little PC board to basically create my own adapter. So the board can use either a Max 232 and 1 microfarad caps, or a Max 3 232 with 0.1 microfarad disc caps, and that way it can either work with 5 volt logic or 3.3 volt logic. The board's really simple. DB25, some pin headers, socket, and a chip. So I thought we'd just slap one of these together really quick and see if it works. So let me find the good glasses as the piles of stuff shift around on the desk here. Get in here and solder. It's like it looks square. I'm happy. The board could have used surface mount. I went ahead with all through hole. In my opinion, it's easier to work with. I know a lot of people say once you get comfortable with surface mount, it's easier, and maybe it is. But you know, this was just a quick and dirty board to get the job done. It's a design I'll release publicly. I mean, there's nothing special here. It's a pretty simple little design. There's a 2x2 pin header here that's used to configure pin 2 and 3 on the DB25, which ones transmit, which ones receive. You could just put a couple of jumper leads in here instead. You don't have to use the pin header. It's just there for flexibility. Still doesn't look square. Got to be a better way to do this than I do it. Just whatever it is, I don't know what it is. Tacked on. This is really laid out for a right angle pin header. I don't have any in my stock currently. I've got some on order. So I'm just going to use a vertical instead of a horizontal here, although you could really use either. It doesn't really matter. And of course, not quite square. That looks fine. There's a second row for a pin header here, 6 position, that's got TTL, or receive and transmit in, well, on this side, and it's got EIA level on this side. Those don't have to be populated because there was enough level shifter chips, or enough level shifters in the package to have 2 more. They're wired up, they just don't go anyplace. The pads here that connect to the DB25 only have 1, 2, 3, and 7 connected. The others are all floating, and that way you could, if you needed to, use jumper wires to get to the other pins you needed for a couple of control signals, whatever you needed to do, or even create a second channel if you wanted to. You know, whatever, it's there, it's optional. I just went ahead and included it because I didn't see any reason not to. These caps are a little bit finicky to get in here. These are cheap caps. The pin spacing on them isn't perfectly 0.1, or different manufacturers or whatever. This just came out of a bin full of these. I just grabbed 5 at random. Oh, come on. Why can't I get those leads to splay a little bit apart, hold the capacitor in? For what I'm doing here, 3.3 volt logic, it'll use a Max 3 232, or a Max 3 232, I said that right, and 0.1 microfarad disc caps. If you were going to have 5 volt logic input, you'd use a Max 232 and 1 microfarad. Either electrolytics here, tantalum, although that would be expensive, It might work with or 1 microfarad disc caps, though I don't know that. And this isn't the final layout of the board. There's actually been a slightly different layout and a bunch of work on the silk screening to just basically make it clear you can build it for 3.3 volt or 5 volt logic. It's not committed, you know, to either one. Those are finicky to solder, especially when I keep bumping the lead of another capacitor with the solder and moving the board. That did not take solder. That little charge pump would not work well without solder. By default, little jumpers here go across horizontally. Oh, if I can get it to go on there. Like so, and like I said, you could just use a couple pieces of wire to jumper this and not have to deal with the pin header and the jumpers. I just, like I said, did it for convenience. That's actually pretty loose on there, which is surprising. I've test fit a number of these. Some of them are really tight. Some aren't. How square does that look? I think it looks pretty square. Let me tack one more on this side. Let's see what we've got. Yeah, it looks square enough to me. It's a little bit tricky here because these are solder pot RS232 connectors. They're meant to have a wire soldered into them, and the little solder pot wants to draw the solder up into it. So you need to make sure you get enough that it gets between the solder pot pin and the PC board. As happened there, it didn't get drawn up under the pin to the trace on the board. Boy, that really didn't want to flow. I think I already said this. So pins 1, 2, 3, and 7 are actually connected to the electronics. 1 and 7 go to the ground on the board. Pin 1 is the signal ground, and pin 7 is the signal ground on a standard DB25 connector, and pin 1 is the chassis ground. And I've just got them both tied here together on the board. All the other pins on the board are just floating, like I said, so you could jumper to them if you needed to. I'm just taking a quick peek at the solder here. Everybody looks happy. I don't need that bit of lead caught under there. And there we go. That's soldered up and hopefully ready to go. So I'll kind of finish with this. Up on the Adafruit, I came across these. I'd never seen them before, and they're just packaged. They're just the little shells for building 0.1 cables in. And I've used a couple of these little 4-ways. You can buy the pre-terminated cables here with the right connectors on them. And you just slide the connector into the shell and it clips in, and it's a really easy way of making up cables. So I made this cable with just a set of these. It gives me a really nice cable here to be able to do this with. On the board I've got +5 here and ground down there. And this will just jumper to the electronics in the computer itself. That is, in this case, the 3.3 volt level logic. So I guess the next step here, hopefully, well, I don't know if I'm actually in camera. Next step is to get the chip plugged in here and go plug this in down the system and see if it works. So sorry for the handheld video here, but we've got the little board we just assembled sitting here. It's plugged into a DB25 to DB9 adapter, believe it or not. It goes around to the TTY0 port on the back of my machine here. And that's because I currently don't have a DB25 to DB25 cable. The interface on the board is jumpered over here inside of the Altair, and this is one of GEOS VT100 emulators that I've mounted inside of the case in a previous video. There's 5 volts coming into this board. It gets regulated to 3.3. The 3.3, come on, focus, gets passed back up the cable again. Wow, focus is being an issue here. To the translator board, and basically the idea of this, and I covered this in a previous video, is if I want to use the VT100 emulator, I simply connect this guy when he's mounted in the back of the case with the cable around to the TTY0 connector on the back of the case, and I'm using the emulator. If I want to use a terminal, I just remove that cable from TTY0 and plug the terminal in. And so it gives me easy versatility from outside the case to either use the VT100 emulator, why aren't you focusing? Or to use, you know, a terminal. So, excuse the handheld video. Let's get down here and get the machine powered up. Let me get it reset. I'm trying to work around the camera here. My start address is F800. I want to examine that address. That's where the Altmon monitor lives. And if everything is good here, oh, sorry for the glare, we should get exactly that, the Altmon logon. So the little board's working, and we can then just do something here with it. Test 00, oops. Test 0000 to 3FFF. We'll test the lower 16K of RAM. And testing away. So the translator board's working. This monitor is connected to the VT100 emulator. So happy with it. It's a good test. The board assembled really easily. It works. Kind of hoped it would. Simple design. And there it is. So with this, I'll wrap this up and see you in the next video.